From the throttle shaft, fuel flows to the AFC or Air Fuel Control section of the pump. The AFC assembly is needed on turbocharged engines to provide the proper fuel pressure to the engine during acceleration. It does this by controlling the fuel to the injectors to an amount compatible with the air supplied by the turbocharger. This effectively controls acceleration black smoke. The main components of the AFC assembly include cover, piston assembly, which includes diaphragm, piston, plunger, spring, retainer, barrel, spring. Let's review some basic terminology which will be used in our explanation of the AFC operation. Air pressure from intake manifold, AFC drain or vent, fuel to injectors, no air adjusting screw, fuel from throttle shaft, internal drain, plunger, spring, air diaphragm, check valve, air pressure is applied to the diaphragm and piston through the inlet fitting of the cover. Increasing air pressure overcomes the AFC spring force, causing the plunger to move in the barrel. As the plunger moves, the passage is uncovered and fuel flows through the AFC. As the air pressure continues to increase, the plunger is pushed in even further, uncovering more area until the fuel restriction is eliminated. When there is little or no air pressure applied to the AFC diaphragm, maximum fuel pressure and flow is controlled by the no air adjusting screw. Under these conditions, all the fuel flow is around the no air adjusting screw. New PT fuel pumps are currently fitted with dual spring AFC assembly. Dual spring AFC is a class fit assembly. A class fit assembly has a tightly controlled clearance between barrel and plunger, ranging from 100 to 160 millionths of an inch. Dual spring AFC incorporates 2 hex screws on the AFC cover. The no air setting is made with the lower internal hex screw. This screw also acts as a positive stop. The AFC plunger setting is made with the top internal hex screw. Advantages of dual spring AFC are: easier to calibrate, cannot be easily tampered with, settings not sensitive to injector drain line restriction, more repeatable AFC setting, no boost pressure on AFC. Dual spring AFC assemblies are available in 2 standard types, standard assembly and shaped port assembly. The standard AFC contains cross drilling in the barrel connecting the AFC inlet and outlet ports. Let's take a look at the working of the standard dual spring AFC. In the no air condition, the AFC in passage is blocked by the AFC plunger. All the fuel will flow through the cross drilling in the barrel. When air pressure is applied, the plunger is pushed forward in the barrel, opening the AFC in passage and allowing fuel to flow through the AFC. On increase of air pressure, the plunger moves even further, eliminating the fuel restriction. The shaped port AFC assembly contains a shaped passage instead of the cross drilling in the barrel. The shape of the AFC in port ensures that there is always some fuel flowing through the AFC. Advantages of shaped port dual spring AFC are: better torque control below torque speed, insensitivity to viscosity during cold engine start, idle and response, better transition curve.